Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is a Probability and Statistics 2 for May-June 2023, and the code is 9709/61. Okay, so let's move on to question number 1. Question number 1. In a certain country, 20,540 adults out of a population of 6,012,300 have a degree in medicine. A. Use an approximating distribution to calculate the probability that in a random sample of 1,000 adults in this country, there will be fewer than 4 adults who have a degree in medicine. Okay, so from here, alright, we know that the n is 1,000. So it is 1,000 adults, means that this is the discrete random variable. Okay, so the x is number of adults who have a medicine degree. And then the p is 20,540 divided by 6,012,300. Okay, so from here, now since your n is large, and then the p is this value. Now let's calculate the value first for the NP. Because initially it is binomial distribution, but now it's mentioned approximating distribution, means that we need to use approximation. Either we approximate to normal or we approximate it to Poisson distribution. So let's check the NP value. So the NP is 1,000 times the fraction, okay, then here you will be getting 3.41633. Now this NP is not the final answer, therefore I will give more decimal places. Alright, so when you calculate this, and you will find that it is less than 5. So since your NP is less than 5, that means this is Poisson approximation to binomial. Okay, so Poisson approximation to binomial. Alright, so now from here, my Poisson, I let it be W. So my W, or probably I will just write my X first. My original distribution supposed to be binomial, NP, so 1,000, and then the P value. Alright, and then from here, it will be approximate to Poisson. So for Poisson, we need the mean. Okay, so the mean for the Poisson is actually the NP. So that means here I will write 3.41633. That's my mean. So now you need to count the probability that it is fewer than 4 adults. So Px less than 4. And then it will be same as Pw less than 4. Now, Poisson is discrete random variable. Binomial is also discrete. Therefore, we do not need to perform the continuity correction. Okay, just solve as usual. Then now, when Pw less than 4 means that it will be starting from 0 until 3. So you need to get the sum of all these probabilities. Alright, now for your information, for Poisson distribution, x is PO, let's say lambda, the probability equals to E negative lambda times lambda to the power of x over x factorial. Okay, so now in this case, our lambda is 3.41633. Alright, so by applying the formula here, I will get E minus 3.41633. Now, for your information, for all these probabilities, the E minus lambda is a constant. the variable will be the x, alright? That means I will factorize the e minus lambda. So I will factorize this e, and then I will write then lambda power x over x factorial. So for your information, when lambda equals to 0, so any value to the power of 0, it will be 1. Then 0 factorial is again 1. So for the first probability, after you have factorized the exponential, I will get 1. Okay, then plus PW equals to 1 means you replace the x by 1 now. So I will get negative 3, positive 3 because our lambda is positive. So I will get 3.41633 degree 1. Okay, plus PW equals to 2 means 3.41633 degree 2 over 2 factorial, which is this part when the x equals to 2. Plus with when x equals to 3. So it's just a cube of the lambda value, then divided by 3 factorial. Alright, so now when you calculate all these values, it will be 0.55479. So now we always leave our answer correct to 3 significant figures. Therefore, it will be 0.555. Alright, so this is the solution for question number 1. Now for B, justify the approximating distribution used in part A. Okay, why do we need to use this distribution, this approximation? So, very simple. The n is 1000, which is greater than 50. And then the MP is 3.41633, which is less than 5. That's why we are using this distribution, this approximation. Okay? Now for question 2, the graph of the function f is a straight line segment from 0, 0 to 2, 1. So 0, 0 to 2, 1. It is a straight line. Now show that f could be a probability density function. Alright, so if you still remember probability density function PDF means that the area, okay, let's say your fx defined from x from a to b. Alright, so the integration of fx from a to b will be 1. This means this is the area. Okay, so from here I need to prove that the area of the area under the curve, or the area under the straight line, is 1. Okay, so now area, now from the triangle we know that the base is 2, the height is 1. So the area of the graph, or under the graph, is half times 2 times 1. That means you are getting 1. Okay, so this is also same as integrate fx dx from 0 to 2. Alright, and another one is your fx from the graph. The fx is always positive, or I would say that the fx is at least 0, because when we refer to the graph here, the y value always above the x-axis. Okay, so hence f could be the probability density function. Alright, so this is the solution for this question. Okay, now B, the graph of the function g is a semicircle. This is a semicircle. Center 0, 0. So this is a center. Entirely above the x-axis. Given that g is a probability density function, find the radius of the semicircle. So since this is a probability density function, that means the area under the graph for this value, from this value until here, it will be 1. So, and then you were told that this is a semicircle with center 0, 0, which is the origin, which means here is radius. Okay, so now we know that area under the curve is 1, which is same as half pi r squared. So that is the r. So now from here, you need to get the radius. Alright, so move the 2 to the other side. So that means 2 over pi. This pi move to the other side as well. So r squared will be 2 over pi. Hence your r, since this is a radius, it should be positive value. So it's square root of 2 over pi. Okay, now see, the time x minutes taken by a large number of students to complete the test has probability density function h, as shown in the diagram. First part, without calculation, use the diagram to explain how you can tell the median time is less than 15 minutes. Okay, so now when you look at the graph here, this is y equals to hx. Now, the graph is defined from 10 to 20. So if it is 15, you want to show that the median is less than 15. So 15 is the midpoint of 10 and 20. That means it is somewhere here. This is 15. Alright? And we know that the area, the total area under the curve is 1. So if median is 15, let's say this is a median, that means this region, this area will be 0.5, and here is going to be 0.5. But then we know that area, the probability 0.5 is also same as area under the curve. So obviously the first area, the area of the first region is bigger than area of the second region. Okay, the region on the right hand side. So that's the reason that the median is less than 15 minutes. Right? Because the probability will be greater than 0.5 due to the greater region. Okay, so to explain this, probably we can just write the area to the left hand side, to the left side, okay, to the left side of 15 is greater than the right hand side, is greater than 0.5. Okay, because the region is bigger. Compared to right side of 15. Hence, median time is less than 15 minutes. Okay, so that's the explanation. Now, it's now given that hx is this function defined from 10 to 20, inclusive both, and hx equals to 0 otherwise. Otherwise means other x values. Find the mean time. So mean time, the mean is same as the ex, expected value. So expected value is integrate x hx with respect to x, and then the x is defined from 10 to 20. So now I will get 10 to 20, x multiplied with these two terms. So 40 over x squared minus 1 over 10. Before we integrate, we need to expand first. Okay, times in the x to the bracket. So now I will get integrate from 10 to 20. X times 40 over x squared means that you are getting 40 over x Then the next term is going to be negative 1 over 10x dx. So for the first integration, right, we know that integrate 1 over x dx, it will be ln x plus c. So this modulus is to make sure that the x is positive. If you are sure that it is positive, then no need to write the modulus. Okay, so here, the first term, where I integrate 40 over x, I will get 40 ln x. I will not write the modulus because my x are positive values, 10 and 20. Then the next one is just 1 over 10 times x squared over 2. Then the limits from 10 to 20. Right? So then, now, when we need to evaluate this, replace the x by 20 first. So you will get 40 ln 20 minus the 1 over 10 and 1 over 2 combined becomes 1 over 20. So I will get 1 over 20, then the x replaced by 20, so I will get 20 squared, minus when the x by replaced by 10, so I will get 40 ln 10 minus 1 over 20 times 10 squared. Right? So when you simplify all these terms, it will be 12.7. So that's the mean time. Okay, now question number 3. In the past, the annual amount of wheat produced by farm by a large number of similar sized farms in a region had mean 24.0 tons and standard deviation 5.2 tons. Last summer, a new fertilizer was used by all the farms and it was expected that the mean amount of wheat produced by farm will be greater than 24.0 tons. In order to test whether this was true, a scientist recorded the amount of wheat produced by a random sample of 50 farms last summer. He found that the value of the sample mean was 25.8 tons. Stating a necessary assumption, carry out the test at 1% significant level. Okay, so from here, when you look at this 24.0, this is the value from the past records. That means this is a mu. Okay, standard deviation 5.2, this is the sigma. Alright, then now you need to write down the necessary assumption. So from here, okay, after this sentence, then you were given the information regarding the sample. This is x bar, sample mean, and this is a sample size. And then the scientist suspect it will be greater than 24.0. Alright, so from here the assumption will be on the standard deviation because your population standard deviation is given. So the assumption means the standard deviation equals to 5.2. Okay, because this 5.2 is the standard deviation from past records. Alright, so now from here this is hypothesis testing regarding the mean. Your H naught is mu equals to 24.0. And then since the scientist suspect it will be greater than 24.0 tons, so it means that is your H1. Mu is greater than 24.0. And then you are testing this at 1% significant level. So alpha equals to 0.01. Now, from the questions, you are given population standard deviation, right? So it will be normally distributed. Means that we are going to use a z-test. So I will sketch a graph, which is bell shape, and by looking at the H1, which is greater than 24.0, that means this is upper tail, one tail test. So I will label this as 0.01. And now I need to find out what is this critical value from the table. Alright. But then when you use the normal table, we need the region towards the left hand side. So we know that area under the curve is 1. So since the right hand region is 0.01, that means the left hand region will be 0.99. Okay, so now you read this value from the table, and then you will find that the critical value is 2.326. Then from here, I will write down my rejection region. Reject H0 if my calculated value is greater than 2.326, which is a shaded region. Okay, and then the next step is to get the exact value, the calculation. So the value is x bar minus mu over sigma over square root n. Okay, so the x bar is given 25.8. So 25.8. This mu is a mu at the H0. That means it's 24.0. Over standard deviation is given 5.2 from the question. Then divided by square root. Your n is 50 farms. So here, when you calculate, it will be 2.448. That means it's going to be okay, I will write both first. 2.448, which is 2.45. Okay, 3 significant figures. Or maybe we can just write corresponds to this, up to you. Alright, so from here, 2.45 is actually inside the shaded region. That means our decision is reject H0. So you can write here, since Z is greater than 2.326, reject H0. So when reject H0, right, refer back to the question. The scientists suspect it is greater than 24.0 tons. Alright, that's the mean amount of the wheat produced. So now since you have rejected the H0, means that we have evidence, right, to conclude it's actually greater than 24.0 tons. It's like supporting the H1. So then here you write, there is sufficient evidence at alpha equals to 0.01 to conclude that the mean amount of wheat produced per farm is greater than that value. .0 tons. Okay, so that's the decision and conclusion for this hypothesis testing. Okay, now let's move on to question number 4. A certain train journey takes place every day throughout the year. The time taken in minutes for the journey is normally distributed with variance 11.2. Now A, the mean time for the random sample of n of these journeys was found. A 94% confidence interval for the population mean time was calculated and was found to have width of 1.4076 minutes, correct to 4 decimal places. Find the value of n. Okay, so now 94% confidence interval for mu. The formula is x bar plus minus. Okay, now let's check. Alright, the variance is given. Okay, therefore we are using the z-test or z-test. So sigma over square root n. Now for your information, the width is double of this. Alright, so width is double of the term. And then now the width is given 1.4076. So 1.4076 is double of, okay, now to get the Z value or the Z value, you need to draw the graph. So I will draw the graph. I will simply sketch a normal graph. It is 94% confidence interval, means that in between is 94%. That means it's 0.94. So now, since we are using the Z test or the Z test, what we need to do is we need to get the total region to the left hand side. So I know that the total area under the curve is 1. So now, middle is 0.94. That means the left and right side will be the remaining values and divided by 2. Okay, the remaining values shared by 2. So which means it is 0.06 divided by 2, I will get 0.03. So 0.03 on the left hand side together with the 0.94 in the middle. So now I have to look for 0.97. What is the critical value when the probability is 0.97? So this can be found from the table. So the table shows 1.881. So that's why I will replace the Z alpha over 2 by 1.881. Okay, and then the sigma here is given, the variance. So now you are given variance and we need to get standard deviation. Therefore, I can just take square root of the variance to be my standard deviation. Over the n is unknown. So from here, I can split it into 2 square roots. I will remain the rest first. So instead of square root of the fraction, I can change to square root of 11 over 2 divided by square root n. Okay, so it will be 1.4076. And now to get the n, because the question asks for what is the n, the whole square root n will be moved to the left hand side. And then the 1.4076 will be moved down. So I will get 2 times 1.881 times square root of 11 over 2, 11.2 over 1.4076. Then this square root n is going to be 8.9443. Then my n, when you square both sides, it will be 80. Okay. Alright, so that's the solution of this question. Now B, a passenger noted the times for 50 randomly chosen journeys in January, February and March. Give a reason why this sample is unsuitable for use in finding a confidence interval for population mean time. Okay, so now the sample is only taken from these 3 months. Alright, and then you are using this 3 months data to approximate the population mean time. Okay, so it is not suitable because, so you write this sample is unsuitable because the sample is not randomly taken throughout the whole year. We always look for a random sample, right? It's not randomly taken throughout the whole year. So that's the reason why this sample is not suitable. Okay, now part C. A researcher took 4 random samples and a 94% confidence interval for the population mean was found from each sample. Find the probability that exactly 3 of these confidence intervals contain the true value of the population mean. Okay, so now, which means your probability is 0.94 to include the population mean, and then the n is 4 now. So from here you need to get the probability exactly 3. So which means this is actually binomial distribution. So X is binomial distributed with with n 4 and the probability 0.94. Okay, so from here, just for information, X is binomial NP, and then you need to count the probability. X equals to small x, it will be NCX, PX, QN minus X. Alright, so, and now you need to find exactly 3. So PX equals to 3. So according to this formula, now the n is 4. I will get 4C3. The P is 0.94. So 0.94 to the degree of 3. Then now the Q here is basically 1 minus P. Okay, so from here I will write Q is 1 minus 0.94, which is 0.06. So I will write here 0.06 degree 1. Okay, then when you calculate this value to 3 significant figures, you'll be getting 0.199. So that's the probability for this question. Alright, now let's move on to question number 5. Large packets of rice are packed in cartons, each containing 20 randomly chosen packets. The masses of these packets are normally distributed with mean 1010 gram and standard deviation 3.4 grams. Okay, so this is for one packet. Now the masses of cartons when empty are independently normally distributed with mean 40 grams and standard deviation 2 grams. Now A, find the variance of the masses of full cartons. So full cartons means that you need to include the empty cartons together with the 20 packs. 20 packets of the rice. Okay, so I will write down this first. Rice is represented by R. It is normally distributed. The mean is 1010. Standard deviation 3.4. So I will write variance is 3.4 squared. And then the cartons, the empty cartons, it will be same, normal distributed. And then the mean now is 50. Standard deviation is 2. So variance is 2 squared. Now when full cartons means 20R together with the empty cartons. Alright, so my 20R, and now we are concerning about the variance. So I will not get the whole distribution for the 20R. So I will just write variance of 20R. So it will be 20 because it's 20 packets. Alright, so it's sum. So therefore, you just have 20. So variance R. We don't square it here. Square is for multiplication. It's a times. Now it is addition of 20 packets of rice. So I'll get 20 times 3.4 squared. Then at last you are getting 231.2. That is the variance for 20R. Now I need to get full carton. So variance of C plus 20R. Okay, so I will write here variance of full cartons equals to variance of C plus 20R. Okay, which is variance C plus variance 20R then you just add up 4 squared, 2 squared plus 231.2. Then you will get 235.2. Okay, so that's the variance of the masses. Now, small packets of rice are packed in boxes. The total masses of full boxes are normally distributed with just now large packets, okay? Just now large packets, now small packets. So the total masses of full boxes are normally distributed with mean 6,730 and standard deviation 15 grams. The masses of the boxes and cartons are distributed independently of each other. B. Find the probability that the mass of randomly chosen full carton is more than 3 times the mass of a randomly chosen full box. Okay, just now carton, now is box. So now, for the box, I will write B. It will be normally distributed. Mean 6730, standard deviation 15. So variance is 15 squared. Alright. So now, I need to get full carton is greater than 3 times the full box. So now, just now, when you refer to the A, I have found the variance of full cartons, but not for the mean. So now I need to get the mean or expected value. So the expected value of full carton equals to E C plus 20R. So it will be EC plus E20R. Okay, so the EC from the previous is 50 plus E20R. Remember, the 20R is a summation of the R. Okay, you sum it for 20 times. So it will be same as 20 ER. So 20 ER, the ER is 1010. Then you will be getting 20250. So from here, I will say that full carton is FC. Alright, let's say full carton, I define first. Let full cartons be FC. So now my FC will be normally distributed. The mean that we have found from previous, the mean is 20250. And then the variance that we have found from previous question, 235.2. So here, 235.2. Okay, and then now we need to get probability of full carton is more than 3 times. So it means that now we need to find P full carton is more than 3 times of the boxes. So which means now we need to get P FC minus 3B more than 0. So since your FC and B are normally distributed, now we need to get the distribution for FC minus 3B. So which means I need to get the expected value and variance for this. Okay, so what I need to do here is probably I will just find out what is my E first, the expected value. So EFC minus 3B is going to be EFC. Remember, this 3 is the times, right? But for the E, there's no effect. Means that minus 3 EB. I get the distribution first. So FC, the expected value is 20250 minus 3 times EB. The EB, B is 6730. So 6730. Then you will get 60. Alright. So now I'll continue here. So now my variance, FC minus 3B. Then this is variance, FC plus 3 square variance B. Because this 3 is a times, right? So it will be 3 squared. That means you will get 235.2 plus 3 squared is 9. Variance B is given in the question, 15 squared. Then you will be getting 2260.2. Okay, so once you have found the expected value and the variance, then I can just rewrite my FC minus 3B is basically normally distributed. The mean is 60. Variance is 2260.2. And now we need to solve this probability. Okay, therefore, P FC minus 3B greater than 0, it will be same as P, standardize it, then greater than 0 minus 60 over square root of 2260.2. Then you will get P standardized normal random variable is greater than negative 1.262. So now, once you get this, sketch a graph. Let's say here is negative 1.262. Here is 0. Since this is greater than means that it is a major region. And now from here we need to reflect because the critical value is negative. So when you reflect, it will be on the right hand side and then the region becomes towards the left hand side. So at the same time your critical value is 1.262 positive. So it means that now you need to find the green region. Alright. So the green region is basically probability that Z or Z less than 1.262. So this value can be found by referring to the table. So table will give you 0.8966 and then now you round up to 3 significant figures, it will be 0.897. Okay, so that's the solution for this question. Now question number 6. A random of 5 randomly selected values of x is as follows. So you are given 5 data where a is greater than 0. Given that an unbiased estimate of variance x calculated from this sample is 11 over 2. Find the value of a. Okay, so from here, unbiased estimate formula is basically sigma squared equals to, this is hat, equals to 1 over n minus 1 summation x squared minus square of summation x over n. Alright, so now you are given it is 11 over 2. But before that, we need to get the summation x and summation x squared first. So I will just show it beside it. So summation x is the total of the x. So just get the sum. 1 plus 2 plus 6 plus 1 plus a. That means this is going to be 10 plus a. Okay, then summation x squared, it will be 1 square plus 2 square plus 6 square plus 1 square plus a squared. So then you will get 42 plus a squared. Now substitute these two values into the formula. At the same time, the unbiased estimate of variance is given, which is 11 over 2. Then now your n is 5. Okay, this is the n. So 1 over n minus 1 becomes 1 over 4. So summation x squared is 42 plus a squared. Then you minus square of summation x. Summation x is going to be 10 plus a. Then you square it over 5. So from here, I can times the whole equation by 4 first, because here is 4. So I times 4. Then 11 over 2 times 4, you will get 22. So the 1 over 4 will be cancelled off. Then I will get 42 plus a square minus, okay, now here I do expansion. Square of 10 plus a. Right, to expand this, you use the formula of a plus b squared, which is a squared plus 2ab plus b squared. Then I will be getting 100 plus 20a plus a squared, then divided by 5. Okay, remember we need to find the a. What is this a? Now you have fraction. You have the denominator of 5. So I will times 5 to the whole equation. So 5 times 22, it will be 110. 5 times 42, it will be 210. Then 5 times a squared will be 5a squared. Alright. Then for the last term, okay, the whole bracket, you can just ignore the over 5 because already cancel off with the times 5. Then open the bracket by multiplying the negative. So when you times in the minus to the whole bracket, all the terms will be minus. Then I will get minus 100 minus 20a minus a squared. Then now I rearrange. Okay, you see here is 5a squared minus a squared. I will be getting positive a squared on the right hand side. So it means that I will move this 110 to the right hand side and get a quadratic equation. So 5a squared minus 1a squared will be 4a squared. Then now minus 20a just remains. Then this 110 move to the right hand side becomes negative. So the negative together with negative 100, it will be negative 210. So negative 210 plus this 210, it will be 0. So I will just write 0. That equals to 0, right? Then from here, the common term is 4a. So 4a will be factorized. Then I will get a minus 5 equals to 0. So means that 4a equals to 0 or a minus 5 equals to 0. So when 4a equals to 0, the a is going to be 0 and the next one a is going to be 5. But then the question is find the value of a, means that there's only one a. So now let's look at the question. It's mentioned that a is greater than 0. So now given a is greater than 0, therefore my a is 5. Okay, so this is the solution for this question. Okay, now question 7. The number of accidents per week at a certain factory has a Poisson distribution. In the past, the mean has been 1.9 accidents per week. Last year, the manager gave all his employees a new booklet on safety. He decides to test at 5% significant level whether the mean number of accidents has been reduced. He notes that the number of accidents during 4 randomly chosen weeks this year. Okay, this is for 4 weeks. This 1.9 accidents is per week for 1 week. So A, state suitable, null, and alternative hypothesis for the test. Since this test is done, okay, or the number of accidents is observed during 4 weeks, any 4 weeks, therefore now I have to find what is my new mean accidents for these 4 weeks. So per week is 1.9. So now it will be 1.9 times 4. Okay, so it will be 7.6. Therefore, your null hypothesis, you can just write lambda equals to 7.6 accidents. Then now, since for this test, the manager, right, decides to test whether the mean number of accidents has been reduced. So if has been reduced means that I will expect H1 lambda is less than 7.6. So these are your null and alternative hypotheses. Now B, find the critical region for the test and state the probability of a type 1 error. So the first is critical region, the second is probability of making type 1 error. So now your alpha is 5%, significant level is 5%. So here I will write my X is Poisson distributed with the mean of 7.6 and then the alpha is 0.05. So for your information, alpha is the probability of rejecting the H0. Okay, so now I need to count what is my X for which the probability will be less than 0.05. That means that it's a critical region because the alpha is the probability of rejection region. Okay, or probability of rejecting the H0. So I will start with Px less equals to 1. So when px less equals to 1 means that it will be 0 and 1. So px equals to 0 plus px equals to 1. Now, for your information, this is Poisson distribution. So the formula of the probability is E minus lambda to the power of x over x factorial. So now, it will be e to the power of negative 7.6. Right, so when x equals to 0 means that it will be 1 plus, then px equals to 1 means that it will be 7.6 after you have factorized the exponential. Then now when you calculate this value, it will be 0.00430. This is less than 0.05. Alright, that means you will reject the H0. This is the critical region, but we need to find what is the maximum x value. So now I will continue with x less equals to 2. When ps less equals to 2 means that it is p x equals to 0, 1, and 2. So I can recalculate all these values. Okay, so px equals to 0, 1, and 2. So then it will be e negative 7.6, 1 plus 7.6 plus 7.6 squared over 2 factorial. Then you will get 0.0188. Again, this is less than 0.05. So now I will proceed with px less equals to 3 to check whether we can accept up to x equals to 3 or not. So again now, here, from the previous, you just add on one more term. So it will be e negative 7.6, 1 plus 7.6 plus 7.6 squared over 2 factorial plus 7.6 cubed over 3 factorial. Okay, so from here, the answer is 0.0554. So this is greater than 0.05. Okay, so now you will reject the H0 if px less equals to small x, which is less than the alpha value. So from here, right, when x less equals to 2, it is less than 0.05. But if it's less equals to 3, it will be greater than that. So when greater than that means that this is no longer the critical region. That means your critical region is x less equals to positive 2. So critical region x less equals to positive 2. Alright, so we have done the first part. Don't forget, you still have second part, probability of a type 1 error. So probability of type 1 error is the probability of rejecting H0. Alright, when the H0 is true. So from here we know that the critical region or reject H0 means that it will be in the critical region. So therefore, the probability will be just this value, 0.0188. So this is same as p x less equals to 2 because that is the critical region. So which is 0.0188. Okay, that's the probability of type 1 error. Okay, now C. State what is meant by type 1 error in this context. Okay, so when you refer back to the definition, type 1 error means reject H0 given that H0 is true. So now when you refer back to the H0, right? What is your H0? Your H0 is lambda equals to 7.6. But now when you reject H0 means that we are accepting H1. Okay? So means that it's basically the number of accident, the mean number of accident has been reduced because it's less than 7.6. Alright? So type 1 error means the number of accidents, the mean number of accidents, because the lambda is a mean. So the mean number of accidents has been reduced. Okay, but don't forget, slash h naught is true. Slash means given that the h naught is true. So your h naught is true means that supposedly your lambda equals to 7.6. Right? Then you cannot stop here. You have to write, although it is not, or it has not. Okay? So given that the lambda remains the same. So that's the meaning of type 1 error in this context. Okay, now D. During a 4 randomly chosen weeks, there are a total of 3 accidents. State the conclusion that the manager should reach. Give a reason for your answer. Okay, so now, from here, 3 accidents means that the x equals to 3. So, go back to the parts B. Okay, when x equals to 3, right, now look at here, when x equals to 3, it is no longer in the critical region because your critical region is, look at here, right, your critical region is x less equals to 2. So when x equals to 3 means that it's outside the critical region, means that you do not reject h naught. Right, so when you do not reject h naught, that means we will say that the lambda remains as 7.6. So on other words, you cannot accept this. Okay, you cannot say that it has been reduced. So now the conclusion is, conclusion is the mean number of accidents, or no evidence, we can say no evidence. Okay, because the manager claims that it has been reduced. So no evidence, or no sufficient evidence to conclude that the mean number of accidents has been reduced. Okay, why is the reason? The reason is because x equals to 3 is not in the critical region. Okay, so that's the solution for part D. Now, E, assuming that the mean remains 1.9 accidents per week, use a suitable approximation to calculate the probability that there will be more than 100 accidents during a 52-week period. So now again, for 1 week, 1.9 accidents. So now we need to find for 52 weeks, what is the mean accidents, mean number of accidents. So 1.9 times 52. So from here, I will get 98.8. Alright, so which is greater than 15. So remember, at first, it is Poisson distributed with mean 1.9. So since it is 98.8 now, which is greater than 15, we will approximate this to normal distribution. So for your normal distribution, we need the mean. The mean is 98.8 and the variance is also 98.8 because for the Poisson distribution, the mean is same as the variance. Okay, and now we need to get probability that is more than 100. So Px more than 100. Now remember, your x is Poisson distributed. That means this is discrete. Okay, now we have approximated to normal. Normal is continuous random variable, or continuous distributed. Alright, so hang on please. Okay, so this is continuous. The Poisson is discrete. So from discrete you change to continuous, means that we need to carry out the continuity correction. So for continuity correction, I will draw a line. Okay, number line. Show 100 because x is greater than 100. So when x greater than 100 for Poisson, it will be 101 onwards. So I will have to accept all these x values. And then according to the continuity correction, you are allowed to plus minus 0.5 from 100. So when minus 0.5 from 100, I will get 99.5. When plus 0.5 from 100, I will get 100.5. Okay, so then my working becomes PW more than. So we will always follow the inequality sign here. When more than means that it will be towards the right side. That means I will have to accept more than 100.5 to include these two ticks. Therefore, I have to write greater than 100.5. Okay, so then now my W is normally distributed, means that now I have to standardize it. So I standardize it by minusing the 100.5 with 98.8, that over square root of 98.8, which is our standard deviation. Then from here, you will get PZ more than 0.171. Okay, once you get this standardized normal random variable, sketch a graph, label 0.171, and then the region is greater than. That means it is towards the right side. And now, when you refer to the normal table, we need the region. We can find the probability towards the left hand side, but not for the right hand side. That means in order to get the right hand side, it will be total probabilities, which is 1 minus PZ less than 0.171, as shown on the diagram here. So here will be 1 minus PZ less than 0.171. Okay, so this PZ less than 0.171 from the normal table, you will get 1 minus 0.5679. Okay, then here is 0.4321. At last, round up to 3 significant figures, it will be 0.432. Okay, so this is the solution of this question. Okay, so that's all for this video. Thank you for watching. Alright, please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.